From yawns to sharp minds, the hidden power of sleep. Hi there, welcome back to my channel and you're watching Curious Bits, a curiosity series packed with tiny doses of science and wonder. How much sleep did you get last night? Science recommends 7 to 8 hours for a full night rest. It may be tempting to stay up for work, for study, do more homeworks, watch more Netflix, but science shows you can sacrifice your brain function. Alright, it's time for today's bit. We are talking about something we all love, but never seem to get enough of, sleep. How does sleep really affect our ability to stay focused? Let's find out. But here's the thing, not everyone who sleeps less will lose focus, and not everyone who sleeps well will stay sharp. That's where uncertainty comes in. And to measure that uncertainty, we use one of science's most powerful tools, probability. Now, let's take a look at our dataset. It includes 374 participants, divided into two sleep groups. About 219 people sleep between 7 and 9 hours, while 155 sleep less than 7 hours. Of all participants, 180 achieved high focus, and every single one of them came from the 7 to 9 hour group. So this is where we start exploring how sleep duration relates to focus using probability. But what exactly is a probability? Before we jump into what probability actually is, let's go over a few basic concepts first. In our case, we have something called a random experiment. That's simply collecting data on people's sleep and focus. Every person in our dataset is part of the sample space, which represents all possible outcomes in our experiment. From that sample space, we can look at specific outcomes, or what we call events. For example, one event could be people who sleep 7 to 9 hours, and another event could be people with high focus ability. These events can overlap, and that's where probability helps us measure how strongly they are connected. In probability, every event has a chance of happening. We calculate it using this simple formula, the number of favorable outcomes divided by the total number of possible outcomes. And this diagram here is a part of conditional probability we're gonna go through later. And if we go through it a little bit, that overlapping area in the diagram shows our favorable outcomes if we're looking at people who sleep 7 to 9 hours and have high focus. For the question of confirming the impact of sleep on concentration level, we first start with the probability of being highly focused. Out of all 374 participants, 180 show highly focused ability, and that gives us a probability of about 0.48, meaning roughly 48% of people in our dataset could stay focused. Next, let's look at the probability of sleeping between 7 and 9 hours. There were 219 out of 374 participants in this group, giving us a probability of 0.59, or around 59%. So more than half of our participants get an optimal amount of sleep. Now, what if one event depends on another? Like your focus depends on how much sleep you get? That's what we call conditional probability, the chance of something happening, given that something else has already happened. Here's the formula for conditional probability. The probability of B given A equals the probability of both A and B happening divided by the probability of A. It sounds technical, but really, it's about connection, how one situation influences another. Let's test it with our data. What's the probability that a person stays focused, given that they sleep for 7 to 9 hours? We take 180 people who are both well-rested and focused, divided by 219 who sleep that much, and get a stunning result, 0.82. That's an 82% chance of staying focused when you sleep enough. happens when you sleep less than 7 hours? The math gives us 0. In our data, not a single person who slept less than 7 hours could maintain high focus. In other words, your brain almost shut down focus mode. So let's compare the results. The overall probability of being focused is 48%, but when you sleep well, it jumps to 82%, and when you sleep poorly, it drops straight to 0. So the data is clear. If you want to focus better, don't just work harder, sleep smarter. So far, we have seen how sleep affects focus, but what if we flip the question? If you are focused, how likely is that you have slept well? And that's where the Bayes' theorem comes in. Bayes' theorem connects the two directions of probability. The probability of sleeping well given you are focused, with the probability of being focused given you have slept well. It helps us reverse our perspective using evidence to infer cause. Now, let's substitute our data. P of high focus given 7 to 9 hours of sleep equals 0.82. P of sleeping 7 to 9 hours is 0.586, and P of high focus overall is 0.481. And now, let's plug them into Bayes' formula. After calculating, we get almost 1, about 0.99 or 99.9%. That means nearly all highly focused people in this dataset sleep between 7 and 9 hours per night. In short, great focus rarely happens without great sleep. So, whether it's study, work, or creativity, your brain runs on rest. Good sleep, great focus. This isn't just data, it's a reminder for all of us. Today, we use uncertainty and probabilities to explore how sleep influences concentration. How about the result? Probability says your focus isn't random, it's conditional on your rest. And that's the beauty of data. It helps us make sense of uncertainty in everyday life. And this is Curiosity, where curiosity meets data, and even your bedtime can become an experiment. Thanks for watching. This has been Curiosity in small doses. And in the next episode, we will keep exploring how uncertainty, probability, and data shape the way we make decisions. Take a break, get some good sleep, and I will see you in the next episode. Here are some Python practice. First of all, we need to upload our dataset into the Google Colab. We first find our dataset. Sleep health and lifestyle. Okay. And then we will see our dataset in the left hand side. And then let's do coding. And here first we need to import the data with this code here. And then after that we will have the result like this. The table of dataset. And then this is a pattern of our dataset we have here. And secondly, we clean data and create some new variables related to the group sleeping. And we will have the result like this. And below are some patterns of the new dataset we have with the new variables. And thirdly, we do some code related to the conditional probability with the question we have here. Does the sleep affect our high focus? The code like this here. And then this is our result. With the conditional probability and biased. It's exactly the result we have in the video. And after that, I do some code like related to the dataset, like we want to do more advanced with the linear regression, logistic regression, chi-square testing. And then after all, we will have the visualization like here. And that's all. Now we do exactly the same in Excel. And first of all, we create new columns here, the slip roof and the high focus here. And then we will insert the pivot table like that. And we will have the cross table. And then we'll do exactly the same in the video, like the probability, conditional probability, and bias theorem. And then we got the result exactly the same.